And this rigid body, it's a cylinder. Let me take a cylinder. And what is this? This is upper belt. This is a lower belt. I want the velocity of point P, velocity of center of mass, and the total kinetic energy of the cylinder. Find VP, VC, and kinetic energy of cylinder, where it is rolling between the upper and lower belts. Where do we see? I think there's a practical diagram will be like this. I think in our book they have shown nowhere such application is there. Usually this will be gears, it will happen. This will be lower gear and this will be upper, this will be lower gear. This is what actually happens here. By moving these belts, so what I can do, I can make that particular gear to rotate. This is what actually the engineering applications will take place like this. But like I don't know why our books have shown like this. This is of no use, nowhere we use the left-hand diagram. This is the correct diagram. In advanced exam, they may trouble you. Don't get confused here. So when this belt moves, what will happen? This will be in contact. No, the teeth will be such that it will make this to rotate. So I'm asking now, what is the velocity of this point? Able to understand? No, it's I think very simplified way of thinking. No, what is the velocity of this point? Velocity of what is velocity speed of this teeth at this instant? What is velocity and what is the total kinetic energy of this? This will appear like a cylinder. Don't bother that deformation at the teeth. Still, you can treat like a cylinder. Now let's get into the problem. So what method you apply? But sir, we don't know what is the angular velocity. So how do it will move? It will roll. So what is the motion of this gear? It will be rotating and also moving forward. So what will happen to this gear? Both translational and rotation. What about this? Only translational motion. This cannot rotate, no belt. So what happened to this cylinder? It will both rotatory as well as translatory motion. But sir, you are not given angular velocity. How it is possible? Yes, we can find out everything. We can even find out the angular velocity also. Sir, about what point it is rotating? If you stand on the ground, it will rotate about center of mass. If you stand at instant center, with the same angular velocity is going to rotate. Okay, how to calculate instant center? So I'm going to circular motion. Already we have discussed this in circular motion. You might have not noticed. So if a rigid body rotates, they can move. What is there? So don't how it is possible? If you have not seen, doesn't mean that it will not occur. If you have not seen, it doesn't mean that it will not occur. Movement of, you type in YouTube, movement of gears between belts, you see numerous diagrams. No, so like I think I was, yeah. No, let's come to the concept. So in circular motion, go back here. If you rotate any plate, you take velocity of this point and the velocity of this point. Agree? What is linear velocity? The plate is rotating. Let's assume this is a center of plate. Nothing to do with problem. I'm just trying to develop the concept. What point there? All these points are rotating above the center. Then for that, what you can do? Draw a velocity. Draw a line joining the head of the velocity vectors. And draw another line. Joining the we'll take this one, joining the tail of velocity vectors where they intersect, where both the lines will intersect. That will be the center of rotation. About that point, in fact, they are rotating. Sir, how do I come to know? This is what I told you. You do rotate. I think every day you take food, lunch, breakfast, dinner. plate will be there, no circular plate. Rotate it. Do some marking and try to see. Sir, but I don't know V1, V2. You do just take marker pen, draw that, and try to rotate. No, where the intersect, that will be the instantaneous center. So now similar method I'll apply it. Similar method I'll apply it. Then, sir, what about this particular thing? I'll take for next problem also. I'll cover here only the concept. Oh, just wait. I'll get back the screen. Okay, now for next one, what we do is I will go for another point here now. The point one, point two, point three. You extend this again. I think the idea is same. 1 and 2 are on same direction, same velocity. So now look at the 2 and 3, they're in opposite direction. Then also what you should do, draw a line joining the head of the velocity vectors and draw another line joining the tail of velocity vectors where the two lines will intersect. That is the instantaneous center. So what, instead of calling C, I'll call instant center. Now, sir, here also you wrote C, that is the center. So here let me call this as instantaneous center. Okay, let's proceed here. Now, what shall I do? Now 2V and V know. So this having 2V means I'll make it little bit vector like this big. So what is the method now? First the tail of velocity vectors. So from here I'll draw a line. In the diagram only I'll show it because I don't have again. Then what I should do? I should draw a line joining the head of velocity vectors. Oh, it's going far away. Huh? Let us come for this one. So is it okay now? This is the instantaneous center. About this point, they are rotating. So what is this? We don't know this. We'll call Y. Now tell me, like, if you stand at point P, what you say? Everything is rotating about this instance with angle of omega, and we don't know this. So how to calculate? Let's see. What is V equal to? Y omega. Then what is this? 2V is equal to? Somebody please mute it. Yeah. Now what is 2V? What is the linear velocity of this point? 2V. And what is the distance? The radius is how much it is? The diameter 2r. So 2V is equal to 2r plus y into omega. Let me equate these two. I'll divide these two. 2 by 2r plus y by y. So 2y is equal to 2r plus y. So therefore, what is y is equal to 2r. So where the instantaneous center of this system is below the rigid body. Somewhere here. There's the instantaneous center. About this point, it's rotating. So now how to calculate omega? Yes, we know y. So what is omega now? Can we calculate omega? Yes, we can calculate omega. Please try to understand. It's a very simple idea, this one. Nothing is there. No concept, nothing. Just information. So now I'll substitute this y there. So what is v is equal to? We know v equal to y omega. And then what is y equal to r? So what is omega now? V by 2r. Now, sir, you tell me one thing, sir. Like, what is this omega? The angular velocity with which all points on the rigid body will rotate about instantaneous center. But omega not given. I'm asking you to find out. That is what I asked you to find out here. If you know omega, then you can tell anything. So I want the velocity of point P. Tell me what shall I do now? I know instantaneous center. It's quite very easy, no? What is the velocity of center of mass? I know instantaneous center and also the angular velocity. Let me get into the problem, the main problem. So I located instantaneous center. I'll let me bring it here. So this was the rigid body. What was the color? Color, blue color. And this was the rigid body. And let's talk about only the rigid body, that one. Just wait, please don't ask anything. Just wait and I'll clarify everything. And now, so where is the instantaneous center? It was somewhere below here. This is how much distance. Now, what is the velocity of center of mass, BC? What is the velocity of this point? It should be, how to calculate that? How to calculate that one? So what I do, I'll draw a radius vector. And we know this is R. And we know this is R. And what is this distance? So what is the angular velocity with which it will rotate? It will rotate with omega. So can we calculate VP? How the direction of VP, the velocity of this point will be in this direction. How to calculate VP? For that we need smaller. What is smaller is equal to root of y square plus r square. 2r whole square plus r square. So this will be how much? R root 5. Then what is the speed of that point P? R into omega. What is R? R root 5. What is omega? We don't know omega. I think we have calculated, no? What was omega equal to? V by 2R. I'm just continuing the previous problem. So that will become V by 2R. So substitute that here, no? What is the speed of that particular point? So this will be root 5 V by 2.
Sir, shouldn't it be y plus r whole square, sir?
What I wrote?
Y plus r whole square plus r square, sir.
Oh, y plus r, no? Yeah. This is here, no? I think I'll make changes here. This will be y plus r whole square plus whole square. What I took, oh, that one, no? Yeah. So this will become total 3r root 10. Check once calculation. 9 plus 1, 10 root 10. Yeah. Root 10 by 2. Okay, check once calculation, and then I'll proceed it. R get cancelled. Okay, this is the velocity. What is the velocity of center of mass? Y plus R into omega. So this will be 2R plus R. Omega is V by 2R. So this will be 3V by 2. I can find out velocity of any point, no? So, but we don't know omega. This is, I brought it. Now what is the kinetic energy of this one? So what it is having both translatory as well as rotatory. This is one best conclusion is what I'm making. Please, all of you try to understand. There's a belt, no? The omega which I was showing about ancient center, the same omega now I'll show about center of mass. The omega I'm showing. So now what's happened? You should question, sir, what is this? In one diagram you are showing omega there, another diagram you are showing omega somewhere, and we should you are saying that don't ask question, just okay, listen, understand. Is your teacher right or your teacher mad? Sometimes showing omega, sometimes omega here. Yes, both are correct. No, who will see this diagram? person on the ground. Who will see this diagram? Person at instantaneous center. When you look at instantaneous center, you see all points are rotating about instant. The total rigid body is rotating about instant center. When you are at ground, what you come in, all points are rotating about center of mass and center of mass is moving. But we don't know omega. That is what unknown thing I calculated. Just if you know the velocity of upper and lower belt, what you can calculate? You can calculate the everything or entire thing about the problem. Now tell me what is the total kinetic energy? Translational plus rotational. What is the translational kinetic energy? mvc square. What is the rotational kinetic energy? ic omega square. You know vc and omega substitute together total kinetic energy of the rigid body. What is k? Total kinetic energy of cylinder or what it's a cylinder, no? What we took? Some cylinder, solid cylinder. Are you able to understand? There's a
Sir,
very yeah.
IC is about the point of about this point, sir.
I
Instantaneous
see moment of
approximation.
inertia. I see m r square by 2. Now you want only rotational kinetic energy. What you should write? Moment of inertia. I think the symbols. This is instantaneous center. Okay, ma. I think that capital IC, small IC. IC is moment of inertia. Mi about center of mass of cylinder. Center of mass C of cylinder. Okay, fine now. I think I'm not confusing you. This omega, that omega. This is what I'll do one thing. The same color I'll give it so that the confusion will get eliminated forever. So just if you know the velocity of belt S means if you just know velocity of any 2 points in a rigid body, you can do anything with the rigid body. That one. I'll give one more similar condition. And now if the velocity of the, you can do it, you can do it. You can do it. You can take that rotational motion about any point. This is